When B-18 exploded during a routine pressure test, most expected SpaceX to pause for months. Instead, within 72 hours, the booster was already being dismantled and its replacement was taking shape. How did they move this fast? The crane arrived November 21st. Cutting began the 22nd. By the 23rd, B-18 was split into sections, while B-19 components were already heading to the megabay. But here's what nobody saw coming. SpaceX just confirmed Flight 12's new launch window, and the timeline is tighter than anyone imagined. Can they actually pull this off, or are we watching the program's most ambitious gamble yet? The speed of SpaceX's response wasn't just impressive, it was almost unsettling. Most companies would spend weeks analyzing what went wrong before touching anything. SpaceX had crews cutting metal within hours. What does that tell us about how differently they approach failure? By the afternoon of November 21st, a massive crane rolled into the Massey facility. No announcements, no delays, just action. The next morning, teams were already positioned around B-18's remains. Then came the first cut, a clean separation between the liquid oxygen tank and the methane tank. This wasn't random. SpaceX deliberately chose to split the booster at this exact point. Why? Because each section told a different story about what happened during that pressure event. The methane section came apart in 3 pieces. Engineers appeared most interested in the forward region near the hot staging hardware. Early observations suggested this area suffered the least damage, possibly because it was furthest from the rupture point. If that's true, SpaceX might actually salvage this section for reference during B-19's construction. But here's the question nobody's answering. If they're moving this fast, what did they already know before cutting started? The liquid oxygen tank revealed something more disturbing. Unlike the methane section, it wasn't immediately subdivided. Instead, workers were spotted welding on the tank dome on November 23rd. Most observers believe they were adding temporary lifting points because the original hardware was on the forward section, the part they'd already removed. Without new attachment points, there was no safe way to move what remained. The welds went on quickly, professionally, like a procedure they'd rehearsed before. Then came the real surprise. When crews finally cut into the LOX tank, they exposed the internal fuel transfer tube, one of the key V3 upgrades everyone assumed would be saved. This tube represented months of engineering work and significant investment. Yet SpaceX cut right through it. Why would they destroy something so valuable? Close examination of the wreckage photos showed a small puncture in the tube. Tiny, almost invisible, but enough. Even a minor hole creates leakage risk under the extreme pressures these systems endure. SpaceX made the call. The entire tube was compromised. No second chances, no attempting repairs. This decision reveals something critical about their safety philosophy. When in doubt, scrap it and build new. By November 25th, B-18 was essentially gone. Some sections headed to the production site for detailed failure analysis. Others went straight to scrap. The entire process from explosion to disposal took less than 4 days. 4 days to dismantle what took 6 months to build. But while B-18 was being cut apart, something else was happening simultaneously. The first major section of B-19 arrived at the mega bay that same morning. Most likely the methane tank, rolled in while crews were still welding on B-18's remains. This wasn't a coincidence. This was orchestrated. SpaceX had clearly started B-19 production before B-18 ever exploded. The question is, how much did they already have ready? SpaceX's official statement mentioned stacking B-19 in December. That sounded optimistic given we're barely past Thanksgiving, but if the methane tank is already at the megabay, the other sections can't be far behind. The liquid oxygen tank, aft section, and eventually the fuel transfer tube all need to arrive and integrate. Based on current pace, full assembly could happen by early January, far ahead of what anyone expected after a catastrophic failure. But here's where the timeline gets really interesting. SpaceX also confirmed Flight 12 remains targeted for the first quarter of 2026. Not might happen or hoping for, remains targeted. That specific word choice matters. It suggests the timeline hasn't fundamentally changed despite losing B18. How is that even possible? The FCC license provides some clues. A leaked update shows a 6-month launch window starting January 23, 2026. This means Flight 12 legally cannot launch before late January. That gives SpaceX roughly 2 months from now to complete B19, run cryogenic tests, perform static fires, and prepare both launch pads. 2 months to do what normally takes 4 or 5. Can they actually compress the schedule that much, or are we witnessing the setup for another delay? Meanwhile, the launch infrastructure tells its own story. On Pad 1, SpaceX has been systematically upgrading the chopsticks. Both arms have had their landing rails removed. The left arm was already trimmed shorter. The right arm is next. These modifications aren't just maintenance. They're preparing for V3 boosters with different catch point configurations. The new design promises more precise movement and better clearance during catch operations. But it also means Pad 1 won't be fully ready for several more weeks. Pad 2 offers a different picture. The ship quick disconnect arm was finally installed on the tower. This isn't the improvised tube-based structure from Pad 1. It's a completely redesigned system. The new arm features a robust steel frame and an enclosed white corridor that looks almost like the crew access arms in Florida. It's far more stable, far more protected from launch forces, but it also appears to be 2 fixed segments rather than the flexible design on Pad 1. Is this a temporary setup or a deliberate design choice that sacrifices flexibility for strength? With both pads undergoing simultaneous upgrades while B19 is being assembled, SpaceX is essentially rebuilding 3 critical systems at once. Any one of these projects would be a major undertaking. All 3 together while recovering from B18's failure seems almost reckless, unless they know something we don't about their production capabilities and testing schedule. Flight 12's mission profile adds another layer of complexity. According to the FCC license, both stages will fly suborbital trajectories, the same approach as Flights 10 and 11. The booster and ship will either return to the launch site or perform water landings. This conservative approach makes sense for the first V3 test flight. SpaceX needs to validate the upgrades before attempting anything more ambitious. But it also means they're not pushing for orbit yet, which raises an uncomfortable question about the refueling timeline. Earlier leaks suggested SpaceX was targeting June 2026 to begin refueling demonstrations. That always seemed aggressive, but it was technically possible if Flight 12 launched in January and subsequent flights maintained monthly cadence. Now, with Flight 12 likely slipping to February, the math doesn't work anymore. To reach refueling by June, SpaceX would need to achieve orbit, deploy payloads, and land both stages in just 4 months. They've managed 2 consecutive launches this year. Maintaining that pace through spring while introducing new capabilities seems nearly impossible. The moon mission looms over everything. SpaceX is contracted to land humans on the lunar surface in 2027, but recent leaks suggest internal targets have shifted to 2028. Every delay in the refueling timeline pushes the moon mission further back. Meanwhile, Blue Origin is accelerating New Glenn development and making real progress on their lunar lander. The competition isn't waiting for SpaceX to recover, yet there's something almost defiant about how SpaceX is responding. They're not slowing down, not calling for investigation pauses, not requesting timeline extensions. They're cutting faster, building faster, testing faster. B18 exploded on a test stand, and within 72 hours they had B19 components moving into position. That's not normal corporate behavior. That's a company that's decided speed is the solution to problems, not the cause of them. But is that confidence justified, or is this where the rapid iteration philosophy finally hits its limits? Because there's a difference between moving fast with rockets that cost millions and moving fast with systems meant to carry humans to the moon. So here's the bottom line. SpaceX turned a catastrophic failure into a 4-day turnaround. B18 exploded, got scrapped, and B19 was already moving into position before most companies would have finished their first safety meeting. That's either genius or madness, and we're about to find out which. Flight 12 is now targeting February 2026. The refueling timeline is slipping. The moon mission is likely pushing to 2028. Blue Origin is closing the gap, but SpaceX isn't slowing down. They're accelerating through the problem. The next 60 days will prove whether this strategy works or backfires spectacularly. I'll be covering every update, every test, every milestone as it happens. If you want the real story behind SpaceX's most aggressive recovery plan ever, subscribe to New Space Review and hit that notification bell so you don't miss what comes next. Drop your Flight 12 launch date prediction in the comments. I'm reading all of them. And if this breakdown gave you new insight into what's really happening at Starbase, hit the like button to help more space fans find this analysis. The countdown has started. Let's see if SpaceX can actually pull this off.